So for number one, we have to determine whether the series converges or not, and if so, to find its value. So this can be rewritten as follows: infinity n equals 1, 3 2n times 2 to the negative 2n minus 1. And if we simplify this, it will be still n equals 1 of 9 to the n times 2 to the negative 2n all over 2. And so our Q ratio will be 9 over 4. And the absolute value of this is still greater than 1. So that means the series is divergent. So for number 2 is to obtain the Taylor series for f of x equals e of x around a equals 1. So first we're going to make our table. And then we're going to evaluate it at a equals 1. And then since all of them are e to the x, they're all going to be e to the 1. And then the formula for the Taylor series is f of a plus f prime of a and then so on. It just continues. So our a is equal to 1. So when we plug this in, it's going to be f prime of 1, and so on. So for our Taylor series, it's going to be e to the 1 plus e to the 1, 1, then x minus 1. And it just follows the formula over and over again. So let me just fill this in. And so on. So our final series is going to look a little something like this. E This is going to be our final Taylor series. So for number 3 is to find the Maclaurin series for e to the 3x. So the formula for the Maclaurin series looks like this. And then this just continues as well. So the first step we're going to have to do is to make another table. So our first one is still going to be e to the 3x. And then that first derivative of that is going to be 3e to the 3x. And then second derivative, you can write 9e to the 3x, but you can also write it like this. Okay, and now we're just going to evaluate these at 0. So for the first one, you can either write 1 or you can also write it 3 to the 0, and then so on. Just going to continue this process. Okay, and then our Maclaurin series is going to be n equals 0, and then it's going to be 3n all over n factorial x to the n, and that's just going to equal e to the 3x. And that's the Maclaurin series. So for number 4, we have to determine whether this series converges or diverges and showing our work. So for this one right here, we can simplify it down. So it's going to be 3n minus 4. And this is going to be 2n plus 6 to the power of n. And then we are just going to take the limit of this. So the limit as n approaches infinity, the absolute value of a of n, 1 over n, is going to equal the limit as n approaches infinity, 3n over n minus 2 all over n plus 6. And this is going to equal 3 over 2. And since this is 3 over 2, 3 over 2 is larger than 1, which means it does not converge. The series is divergent.